So this video is day 2 homework, evaluating expressions in function notation. First, I just want to talk to you about what a function is. A function in general is, you can think of it as this function machine, where you have an input, you input a value, and the function machine works, and then you get an output. Now the key is that for each input you put in, you can only get out one output. So if you put in a 1 and the machine spits out a 4, every single time you put in a 1, you have to get out a 4. If you put in a 1 and you get out some other number, it can't be a function anymore. That's the definition of function. For each input, you can only have one output. So how we're going to look at the function machine is by actually dragging numbers into the function and seeing what happens. So if I drag a 1 into the machine pops out a 1. If I drag a 2 into the machine pops out a 4. If you drag a 3 into the machine pops out a 9. If you drag a 4 into the machine, it pops out a 16. Okay, so your job is to figure out what is happening to the inputs in order for the machine to pop out the outputs. Now I'm noticing that 1 stays the same, 2 gets multiplied by 2, but 3 didn't get multiplied by 2 because that'd be 6, so that can't work. So it's got to be something different than multiplication. Well, what if it's, see, it's tricky because 1 stayed the same. So how is that possible? It looks like if you kind of go through your options, adding can't be it because 1 stays the same. Same thing with multiplying. The only thing you would multiply by 1 to get 1 is 1. So it looks like they're getting squared. 1 times 1 gives you 1. 2 times 2 gives you 4. 3 times 3 gives you 9. 4 times 4 gives you 16. So I'm going to test it out. I'm going to say 5 would give you a 25. And so 6 would give you a 36, and 7 would give you a 49. So if you look at my if you look at my table, 1 goes to 1, 2 goes to 4, 3 goes to 9. And so what's really happening, I'll put this in red, as you can see, they're being multiplied by that x value. So if you want to come up with a rule for in general, so if you wanted to plug in the number 156, you could say I'm doing x times x. And that gives me my y value, or x squared. Another way to write that is x squared is equal to my y value. And that's my function machine. My function here is when I plug in the value x, I get out x squared, which is my output value, my y value. That's basically what this page is saying. It's saying that when you use a function, you put in x values, they are known as the input or the domain, and you get out y values. A y value is called an output or a range, and for each x value or for each input, you get out one and only one output. So I'm going to kind of revise my chart over here, and I'm going to label these. These are the inputs. These are the domains. These are the outputs. And another word for them is the range. So our inputs are 1, we include a 1, we include a 2, we include 3, 4, 5, and 6, and we included an x in general. Our outputs were 1, 4, 9, and then we got our y values. And those are our outputs. The other thing I wanted to write was that these can be written as ordered pairs. You plug in a 1, you get out a 1. You plug in a 2, you get out a 4. You plug in a 3, you got out a 9. You can think of these as ordered pairs also. What we're doing today is we are evaluating functions in function notation. And the basic gist of this is that instead of using y equals, where did I put that? There it is. instead of using y equals 3x plus 1, and then I would tell you where x equals 5, instead of doing that, I'm going to tell you in the equation what x equals. Instead of a y, I'm going to say f of 5. So what I'm doing is I'm taking this y, and I'm using f of 5 instead. And all f of 5 means is I am doing a function where x equals 5. It's just a little bit more explicit than saying y equals. And then you would say f of 5 is equal to 3x plus 1. And then instead of me having to tell you, oh, x equals 5, now you know that x equals 5. So you can say, oh, instead of an x, I'm going to plug in a 5. And then I can solve. 3 times 5 is 15, plus 1 is 6. It's just a shortcut, I would say, because I don't have to write this. And mathematicians love shortcuts. In fact, I think pretty much the whole mathematical language is because we want to be more efficient as mathematicians. The way that you read this is you say f of x, and it literally means a function of x. You don't have to always use the letters f and x. You could use g of x, h of a of t, and what you're saying is that f of x is the same as y. Here's a couple more examples. The function is f of x equals 2x plus 1, and I'm telling you that instead of an x, I'm going to have you plug in a 3. And so then every place you used to see an x, you plug in a 3. And you get f of 3 equals 11. Over here, instead of an a for g of a, every place we see an a, we're going to plug in a negative 2. So that's what you see there, negative 2, negative 2. And then they go through and they solve for g of negative 2 equals 14. I'm going to do the store button in class. The basic gist is that if you want to check if f of 3 is really 11, what you could do is you could plug in x, and you could say, I want x to be stored as 3. And then press enter. And then if you tell the calculator that you want x to be 3, then every time you plug in an x, it will register it as a 3. So you could then type in 2 times x plus 5. You could type in this guy, and you should get out 11. And that's a really great way to check your work. I will do that in class when we all have the calculators in front of us, but that's just kind of an overview. Here are a couple of functions that we're going to use, and we're going to use them on this whole page. So every time you don't know where I'm getting something, look above so you can see where I got the function from. For example, g of 10 is really g of x equals negative 3x plus 1. That's where I'm getting that from, directly above. And so they don't want g of x, they want g of 10. So what I'm going to do is I'm going to think about, okay, this 10 is going in place of this x. So everywhere I see a 10, I'm going to put, everywhere I see an x, I'm going to put a 10. And so this is how you evaluate functions using function notation. You plug in the value that they give you. So they gave you 10. And remember, this isn't negative 310. This is negative 3 times 10. And then you can use your order of operations. Negative 3 times 10 is negative 30. And negative 30 plus 1 is negative 29. And that's your answer for that one. F of 3. I'm going to, again, write the problem. Please don't skip this step, because when your eyes go up to the top of the page and then come back down, sometimes you make a mistake in copying what you write. And if you write it again, then it's literally, in a centimeter above where you just wrote it. So it's less likely that you'll make a mistake. Every time I see an x, I'm going to plug in a 3 now, f of 3. So I'm going to take, I'm going to use red for my variables. The 3, I'm going to plug it in every place I see an X. And so I get f of 3 equals 9 plus 7, which is 16. Same thing with h of x. H of x equals 12 over x. This is telling me h of negative 2. So every place I see an x, I'm going to put negative 2. Ooh, I don't like that. There we go. And so you now see that you have 12 divided by negative 2, and that is equal to negative 6. Okay, now, you can also plug in a variable. J of 7 is just like A, B, and C, but E says H of A. So instead of plugging in a number, you're actually going to be plugging in a variable. You're going to be plugging in A for everywhere you see an X. Instead of this X, I'm going to be plugging in an A. So we have H of A is equal to 12 over A. 12 over A divided by A. I can't simplify that in any way, so my answer in this case is actually an expression, not a number. And you're going to do the same thing over here. G of x is equal to negative 3x plus 1. And this one's really interesting because it's b plus c. And so I'm going to do g of b plus c, and I'm doing negative 3 times b plus c plus 1. And I want you to notice that I put that b plus c in parentheses, and that's because I was multiplying by the whole thing, b plus c, not just the b. You want to make sure you're multiplying by the quantity b plus c. You could leave it like this, negative 3 parentheses b plus c plus 1, or you guys know that when you see a number outside of parentheses, you can distribute. So your final answer is negative 3b minus 3c plus 1. And that's your final answer for that one. Because it's not able to be simplified anymore. You're not going to get a number. You plugged in more letters, so you're going to get an expression. Now this is interesting. Find x if g of x is equal to 16. Very different from the one above. Let me use purple. For J of 7, I'm telling you what x is. For H, find x if g of x is equal to 16. I'm telling you what's coming out. I'm telling you the output. I'm telling you the y value. This is the input. Okay, so when I write g of x is equal to negative 3x plus 1, I'm not plugging in for x this time. I know what g of x is. I know what this is. So that is 16. Okay, and then you can solve this just like any other normal problem where you're solving for a variable. You circle, you draw your line, you minus 1 on both sides. You get 15 equals negative 3x. You divide both sides by negative 3. You get negative 5 equals x, and you're done. You figured out what variable works. When you plug it in for x, you get out 16. We're going to try it again over here. Your original problem was 12 over x. And now I'm telling you that the answer is negative 2. H of x is negative 2. I'm just going to plug in -2 as my answer, and I'm going to have your input. What did you input to get out -2? I'm going to put -2 over 1 so that I can cross multiply. If it looks like it could be a proportion, try putting one of the numbers over 1 so that you can cross multiply easily and figure out what your answer is that way. Then you divide both sides by -2 and you get -6. And the last one, I have f of x. And I remember from above that it's x squared plus 7. And again, I know that answer is going to be 23. So I'm going to plug 23 in for the answer. Same type of thing, you draw your line, you circle your variable because you can't touch it. -7 minus 7, you get 16 equals x squared. And I don't know if you remember how to undo a perfect square. We did this when we were doing radius because the area equals pi r squared formula has the radius squared in it, and you had to undo that. Now when we did the radius could never be a negative number because it was a distance. But we're not dealing with distances right now. We are dealing with algebra. And in algebra, you can have negative answers. So what this is really saying is what number squared, or what number times itself gives you 16? Well, there's actually two answers. 4 times itself, 4 times 4, gives you 16. And -4 times -4 also gives you 16. So you actually get two answers when you do square root. The reason why we don't get two answers when we're doing a square root with radius is because you can't have a negative distance. Not possible. When we do equations, we're going to be using these number properties a lot, so I'm just going to review them with you because you can justify the steps in solving an equation by using these number properties. Say you need to switch the order of two numbers so that you can add them together, do some combining of like terms. You might use the commutative property. The commutative property says you can switch the order of two numbers when you're multiplying or adding, and you'll still get the same answer. The associative property is when you can change where the parentheses are in adding or multiplying, and the answer won't matter. If you add 4 plus 3 in parentheses plus 5, that will give you the same answer as 4 plus in parentheses 3 plus 5, because adding doesn't matter the order in which you group things either. The same thing is true for multiplying. Distributing is one that we've worked a lot on last year. We did it with algebra tiles, and the basic gist is that you can multiply the outside number by both of the inside numbers to get an equivalent expression. That's the distributive property. Because it's really saying 4 groups of 6 plus 2 or 3 groups of 6 minus 2. The additive identity. Okay, additive identity and additive inverse are all about the number 0. The additive identity is that you add 0 to get back the same number. So if I do a plus 0, I'm going to get a. The additive inverse is that what number could I add to a to get 0? And you add the opposite. You add negative a. What number could you add to 6 to get 0? You add negative 6. So the additive identity and the additive inverse are all about 0. Multiplicative identity and the multiplicative inverse are all about 1, because you multiply a number by 1 to get back the same number. 5 times 1 gives you 5. And what number can you multiply by itself to give you 1? Well, that's called the reciprocal. I sometimes refer to it as the flip also. These ones are super important because we actually used it a lot last year when we were doing unit rates. We would do like 1/2 divided by 1/4, and you'd actually use the multiplicative inverse to find that answer. And the last one is the multiplicative property of 0. Anytime you multiply a number by 0, you're going to get 0. And that is the video on evaluating in function notation. And you're going to practice it in class tomorrow. Thanks. Bye.